So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle, it's way thicker. And this is the core. Wait, what's happening here? Uh-oh, the core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian Plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time, and as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half-mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow!
If you had landed on Earth a really, really long time ago, about 1.5 billion years in the past, you wouldn't have recognized our planet. At that time, all the land was stuck together in one giant supercontinent called Nuna, which was surrounded by an endless ocean. But if you had stuck around, you would have witnessed a planetary-scale disaster, Nuna falling apart. But the most amazing thing is that apparently, when Nuna started breaking apart, it kicked off changes that made Earth a much better place for life. Scientists used to call this part of Earth's history the boring billion. It lasted from about 1.8 billion to 800 million years ago. Not much seemed to happen during that time, hence the name. No big climate changes, no bizarre life forms, and nothing very dramatic. Turns out the name isn't very fair. Things may have looked calm on the surface, but underneath, Earth was changing a lot. Continents were moving, splitting apart and coming back together. Two massive supercontinents, Nuna and later Rodinia, formed and broke up during this time. When Nuna began to break apart, huge cracks opened between the drifting land pieces. Water filled those spaces, creating shallow seas. Those seas were warmer, calmer, and had more oxygen than the deep oceans that existed before. And that might have changed everything. The new seas created friendlier conditions for life to grow and change. Scientists now think they may have helped early life become more complex. They looked back 1.8 billion years and rebuilt how Earth's tectonic plates moved over time. Plus, they tracked how carbon was stored inside the planet and released into the air. The researchers did this using a new advanced computer model that gave way more detail than they had ever had before. They found out that during the 350 million years of the so-called boring billion, the amount of shallow seas along the edges of continents doubled. Altogether, these coastlines stretched about 81,000 miles. That's more than 3 times around Earth at the equator. At the same time, subduction zones, places where one tectonic plate slides under another, actually got shorter as the continents shifted around. This is important because subduction zones are where a lot of volcanoes come from. When one plate sinks under another, seawater gets dragged deep into the Earth. That water helps rocks melt, creating magma. The magma rises, erupts as volcanoes, and releases gases like carbon dioxide into the atmosphere. So when there were fewer subduction zones, there were fewer volcanoes, and less carbon dioxide was pumped into the air. It went like this. The supercontinent Nuna broke apart, and it created lots of brand new ocean floors in young seas that didn't exist before. These new ocean floors pulled carbon dioxide out of the air. Seawater flowed into cracks in the ocean floor. When that happened, carbon got trapped in rocks, forming limestone. Over time, this process locked carbon away inside Earth instead of letting it stay in the atmosphere. With less carbon dioxide, Earth slowly cooled down. That cooler climate helped the new shallow seas become stable and rich in oxygen. Such calm, oxygen-filled environments are perfect for life to become more complex. Those huge shallow seas near the continents acted like safe nurseries for early life. They may have helped eukaryotes evolve faster. Eukaryotes are living things with complex cells. Cells that have parts inside them, like a nucleus that holds DNA. Every animal, plant, and fungus on Earth comes from these kinds of cells. So when eukaryotes appeared, it was a huge moment in the history of life. Scientists already knew that eukaryotes showed up during the boring billion because of fossils that are about 1 billion years old, but they didn't really know why this happened at that time. Now, scientists want to find better preserved early eukaryote fossils to learn exactly how complex life first evolved. Life on Earth started over 3 billion years ago. It began with tiny, simple microbes and slowly turned into a huge variety of living things. We still don't have a clear answer about how living things came out of that early primordial soup. But even though there's no final answer yet, scientists have come up with several theories to try to explain how life on Earth may have started. Some scientists think lightning helped start life on Earth. The idea is pretty simple. Lightning is a powerful spark, and sparks can cause chemical reactions. In a famous experiment from 1952, scientists showed that electric sparks could turn simple gases like water vapor and methane into amino acids and sugars, which are basic building blocks of life. This suggested that lightning and early Earth storms might have helped create the first life ingredients. But later research showed Earth's early air wasn't exactly like the experiment. Still, some scientists think volcanic clouds could have had the right gases and lots of lightning, making this process possible. Other experts think life may have started on clay. One researcher suggested that tiny clay crystals could grow and stick together in patterns. As they did, they could trap simple molecules and line them up in organized ways. Think of clay as a kind of early organizer. Today, DNA tells molecules how to line up and work together. But what if clay had been doing a similar job before DNA even existed? It could be helping molecules arrange themselves until they eventually learned to organize on their own. This idea was interesting and got a lot of attention, but most scientists don't fully accept it yet. Another popular theory is that life started at deep-sea vents on the ocean floor. These vents are cracks in Earth's crust where super hot water shoots out from deep inside the planet. As the water rises, it picks up important chemicals like carbon and hydrogen, which are key ingredients for life. The vents are full of tiny rock spaces where these chemicals could collect, mix, and react. The rocks may have helped speed up these reactions. Even today, deep-sea vents house rich ecosystems, even though it's dark there and the whole environment is kinda extreme. Scientists are still studying this idea. In 2019, researchers even created early life-like structures in lab conditions similar to these vents. Such an experiment showed that this theory could really work. Another idea is that life may have started under ice. Scientists believe Earth's oceans might have been covered in ice around 3 billion years ago. Sounds pretty severe, right? But the cold may have actually helped life get started. Many of the chemical building blocks of life, like simple amino acids, are more stable at low temperatures. In warmer water, these molecules break down quickly and are spread far apart. But when water freezes, it pushes those molecules together, increasing their concentration. This crowding makes chemical reactions more likely. So, let's say the molecules were packed closer together and were breaking down more slowly. In this case, they had more chances to link up and form more complex structures. Ice may have also acted like a protective blanket. It could shield the water from harmful ultraviolet radiation from the sun and from damage caused by meteor impacts. Another idea is that life didn't start on Earth at all. This theory is called panspermia, and it suggests that life came from space. Scientists know that big asteroid impacts can blast rocks off of planets. For example, rocks from Mars have been knocked into space before, and some of them ended up on Earth. Some researchers think tiny microbes might have survived inside space rocks during the journey. If that's true, life here could have started thanks to visitors from Mars, or some other cosmic world. Others go even further and suggest that life could have traveled on comets or space dust from completely different star systems, hitching a ride across the galaxy. At the same time, even if panspermia is real, it doesn't fully solve the mystery. It just moves the question somewhere else. Instead of asking how life began on Earth, we'd need to ask, how did life begin anywhere in the universe? While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco. It started as a routine cleaning to scoop some mud off the coast of Indonesia, but turned into a discovery of remnants of a lost, submerged, Ice Age landmass. Archaeologists found more than 6,000 fossil fragments, and among them, 140,000-year-old Homo erectus remains. This find made scientists rethink how early humans lived, moved, and interacted in Southeast Asia. For years, they thought that Homo erectus on Java Island lived in isolation, separated from the rest of the world. But these dredged fossils blew that story apart. It turns out Java wasn't an island at all back then, but part of a landmass called Sundaland. So, Southeast Asia stretched out like someone had drained the ocean, connecting Indonesia, Malaysia, Borneo, Thailand, and Vietnam into one gigantic landscape. Today's islands of Java, Sumatra, Borneo, and Bali were connected by river systems that probably looked like the Amazon, by forests where giant animals roamed, and by coastal plains that would later sink beneath the ocean when temperatures went up. And Homo erectus were not stuck. They were thriving in what honestly sounds like prehistoric bliss. Yep, it was nothing like we normally imagine Ice Age, a sort of frozen wasteland. Sea levels dropped more than 400 feet because so much water froze into glaciers. When all that water got locked up in ice, whole sections of the ocean floor popped out of the water like stepping stones. Suddenly, early humans didn't need boats. They could literally walk from what's now mainland Southeast Asia all the way to places that are islands today. They could do it while exploring and chasing herds across open land. It was sort of like a giant prehistoric highway system. That giant highway matters because it completely rewrites how early humans moved around. Instead of being trapped, Homo erectus had a whole continent to roam. They followed rivers, crossed valleys, and adapted to different environments the same way you learn shortcuts to the office or find new routes to your favorite coffee shop. And because everything was connected, animals wandered freely too. Tigers, elephants, supersized cows, and turtles the size of small cars. People followed these big animals. This among the fossils pulled from the Madura Strait, such as cut-marked turtle shells and cracked open bovid bones. When you see precise cut marks on bone, it means someone was deliberately carving meat off the bone with tools they made themselves. And cracked bones mean they were taking out marrow, which was like prehistoric energy gel, rich, fatty, and perfect when you need calories to survive. That's a level of planning and skill scientists didn't expect from Homo erectus. It pushes Homo erectus closer to species like early Homo sapiens and Denisovans when it comes to behavior. It means they weren't just surviving on scraps, they were actively pursuing animals, processing, and maybe even sharing food the same way later humans did. So if you imagine them as slow, hunched cavemen, forget that. These people were sharp. The techniques they used to process food look eerily similar to those used by other hominins. Not just Homo erectus, we're talking Homo floresiensis, Denisovans, and early Homo sapiens. That opens the door to the possibility that these groups didn't just exist side by side. They might have interacted. Maybe they traded ideas and copied techniques. Or maybe they even interbred or shared territories. All this makes Southeast Asia look not like a series of isolated islands, but like a buzzing human ecosystem, a place where different human species crossed paths. And here's the heartbreaking part. Everything we know about this place, everything humans built, lost, and discovered there, is all underwater now. When the Ice Age ended, glaciers melted like forgotten ice cream cones on a hot sidewalk. Sea levels rose. Slowly, then quickly, rivers flooded, coastlines vanished, entire human landscapes disappeared beneath the waves. Sundaland drowned over thousands of years, and the people who lived there either adapted or moved to higher ground. Archaeologists now try to interpret what these people did, how they lived, and how many human species walked that land. Every time they pull together bone or artifact from the seabed, we get one step closer to rewriting everything we thought we knew about early human migration. And the new discovery could mean that Southeast Asia may have been just as important to human evolution as Africa, the Middle East, or Europe. Looks like Sundaland wasn't a side quest, but a real mixing zone, a place where humanity experimented, adapted, learned, and evolved. Unexpected finds like this one in Indonesia keep popping up around the world and surprising scientists. Farmers in China were hoping to scoop up bat droppings for natural fertilizers inside a narrow limestone cave. But instead, they spotted pieces of fossilized bone that looked suspiciously like parts of a human skull. This skull turned out to be ridiculously old, around 300,000 years old. Scientists eventually named the fossil Maba 1. The discovery happened way back in 1958, but ever since then, nobody could agree on which ancient human species this skull belonged to. During the late Middle Pleistocene, the world was basically a crowded highway of different ancient human species wandering around. Or just maybe, Maba 1 came from a species we've never met before. The big issue was that researchers only found part of the skull, no jaw, no other bones. So it was like trying to solve a giant puzzle with half the pieces missing. For ages, scientists guessed it might be Neanderthal. But now they've used micro-CT scanning, which is like an X-ray superpower that lets you peek inside fossils without breaking them. That's when they noticed weird tube-like structures connecting parts of the brain case, something Neanderthals basically never had. The inside shape of the skull looked way more like Homo erectus, a much older human species. But even that wasn't a perfect match. The skull's size and shape were closer to modern humans and Neanderthals, and it showed traits Homo erectus usually didn't have. For example, it had a shorter forehead area and a thickened bregma, the meeting point between two skull bones. Maba 1 also had a strange dent on the forehead, almost like a bruise frozen in time. Whatever caused it, maybe a fall, maybe anemia, it happened while the person was alive. But there was no sign of infection, so that individual probably healed and kept living after whatever hit them. So Maba 1 doesn't match any known species perfectly, but it shares features with several and has a similar mystery fossil vibe as others found across Africa. In 1976, a famous paleontologist and her team found another human-like skull in Tanzania. That skull had features that looked surprisingly similar to Homo sapiens, even though it was unbelievably old. Scientists think it may be one of the earliest examples of our species ever discovered. That means this skull could help solve one of science's biggest questions. When exactly did Homo sapiens first show up? The sediment layer where that skull was found goes all the way back to the Middle Pleistocene. That's way earlier than what old textbooks used to claim about when modern humans appeared. And then there's a skull that turned up in Zambia's Broken Hill ore mine. Miners literally stumbled on it, plus a few other bones, completely by accident. Scientists started calling it Rhodesian Man, and at first, everyone thought it might be the big missing link between Homo erectus and Homo sapiens. But with newer research tools and better dating methods, they discovered it's around 299,000 years old and probably belonged to someone from the species Homo heidelbergensis. Every new fossil acts like a missing puzzle piece on the giant chaotic story of human evolution. Each one helps scientists connect species that once seemed unrelated, redraw family trees, and rewrite chapters of our past we didn't even know were wrong.
If you wander about 1,800 miles from Madagascar into the middle of, well, basically nowhere, you'll reach the Kerguelen Islands. This remote French territory is one of the most isolated places on Earth. There's no airport, no native population, not even Wi-Fi, just brutal winds, freezing rain, and rough seas. But this place also hides a massive secret beneath the water, because what you perceive above sea level is only the tip of something far bigger, the peaks of an enormous landmass that mostly sank into the ocean. We're talking about the Kerguelen Plateau, a lost, sunken continent. This is a big, mostly submerged volcanic plateau in the southern Indian Ocean. It sits about 1,900 miles southwest of Australia and is nearly 3 times the size of Japan. But don't bother trying to spot it on a world map, because to really see it, you'd have to dive deep. And I mean that literally, since big chunks of it now lie more than 6,000 feet under the ocean. Now, it wasn't always like this, though. For long stretches of time, large parts of the Kerguelen Plateau were above sea level, forming a huge microcontinent. That was roughly between 100 million and 20 million years ago. Back then, scientists think this land was covered in dense forests, packed with trees like araucarias and cypresses. But it wasn't exactly peaceful. Active volcanoes were everywhere, with lava flows probably spilling across the land. And not to mention the dinosaurs. There's some evidence that lizards and dinosaurs once lived there, but they were likely the smaller ones, not the big scary kind. Another cool theory is that the Kerguelen Plateau once acted like a long land bridge connecting Antarctica and India. People believe that for a long time, but more recent research suggests it's probably not true. Even back then, there were still huge stretches of open water separating these landmasses. But anyway, today the trees are gone, and those ancient volcanoes are quiet, hidden underwater. So, you might be wondering, how did this whole chunk of continent sink and basically disappear? Well, we'll get to that in a second. But first, we need to answer a basic question. How did the Kerguelen Plateau form in the first place? Well, our story starts about 130 million years ago. Back then, Earth had Gondwana, a giant supercontinent that included what are now South America, Africa, India, Australia, and Antarctica. But eventually, it began to break apart. And during that long, dramatic breakup that happened over millions of years, the Kerguelen Plateau was born. And it basically exists thanks to something called the Kerguelen hotspot. The Kerguelen hotspot is a region deep inside Earth where super hot melted rock slowly rises toward the surface. You can think of it like a steady underground burner, melting rock in the same spot for a very, very long time. And even though the hotspot stays put, Earth's outer shell keeps moving above it. So as the seafloor drifted over the Kerguelen hotspot, huge amounts of melted rock spilled out, cooled down, and stacked up, layer after layer. Over about 30 million years, that process built a massive mound of volcanic rock on the ocean floor. At the peak of the eruptions, it may have added around 7 to 8 inches of lava every year. To put that into perspective, that's enough new lava to fill about 184,000 Olympic-sized swimming pools, if there were that many. And little by little, that volcanic pile kept growing, bigger and bigger, higher and higher, until it finally rose above sea level and became the Kerguelen Plateau. But then, something strange happened. Over the last 20 million years, this landmass started to sink, slowly but steadily. Today, most of it sits roughly 3,300 to 6,600 feet below sea level, and only a couple of spots have managed to stay above water. One of them is the Kerguelen Islands, that French territory we mentioned earlier, and the other is the McDonald Islands, which belong to Australia. Okay, but how did all the rest of it sink? Well, continents don't end up underwater because they suddenly drop like stones. Instead, this process happens because Earth's surface slowly bends, stretches, and shifts over very long periods of time. The outer shell of the planet is broken into huge pieces, the tectonic plates. These plates float on a hotter, softer layer of rock beneath them, known as the mantle. When a continent gets pulled apart by forces deep inside Earth, its crust stretches out, gets thinner, so it starts to sit lower. And as it drops, the ocean doesn't come rushing in all at once. Instead, seawater slowly spills over the edges, flooding the lowest areas first and turning dry land into shallow seas. Meanwhile, the rock underneath cools down, and when it cools, it contracts and sinks, which pulls the surface down even more. On top of that, sediments keep piling up, almost like heavy blankets, adding extra weight and pushing the crust lower and lower. And that's basically what happened to the Kerguelen Plateau. Parts of it once rose above sea level and even had forests, but the sheer weight of all that basalt, along with shifting tectonic plates, gradually pushed it back down into the deep ocean. In the end, only the highest volcanic peaks stayed above water, and those are the islands we see today. Now, here's a big question. If most of it is underwater, can we still call it a continent? Well, in a way, yeah. In fact, scientists have described it as a microcontinent since the 1970s. And that's because what really separates continents from ocean basins isn't whether they're above water, it's the type of crust underneath. Earth basically has two main kinds of crust, rising and deep dish. Wait a minute, that's pizza crust. Oops. The Earth's crust comes in either continental or oceanic. Continents are made of continental crust. It's thicker, lighter, and usually much older, so it tends to sit higher and form land. It's also more granite-like in composition, formed from magma that cools slowly deep underground before it hardens. Then there's oceanic crust. That's what the ocean floor is made of. It's thinner, heavier, and much younger, so it sits lower and stays underwater. And it's mostly made of basalt, formed when rock in the Earth's mantle melts and rises up. Now here's where the Kerguelen Plateau gets really interesting. Even though the whole region is basically underwater, it isn't just normal ocean floor. And even though it's built from huge amounts of basalt, it doesn't behave like typical oceanic crust. Since this basalt was piled up over millions of years, the crust there became much thicker than normal oceanic crust. It also contains fragments of continental crust from the breakup of Gondwana. So that's basically why we consider it a continent. But you're not going to see the Kerguelen Plateau listed as one of Earth's main continents, just like Europe or Africa. And honestly, that's mostly because it would be a headache. A lot of people don't realize this, but the way we label continents is based more on convention than on one strict scientific rule. Because if we started teaching that the Kerguelen Plateau counts as a continent, we'd have to take a serious look at a bunch of other places too, like Zealandia, this almost completely submerged chunk of continental crust in Oceania. And it doesn't stop there. There's Beringia, Doggerland, Mauritia, Sahul, and Sunda, all regions that were once dry land or made of continental crust but are now partly underwater. So, imagine if we started calling all of them continents. Earth would go from having 7 continents to what, 10, 12, more? It would get confusing fast. That's why the Kerguelen Plateau is usually described as a microcontinent or a sunken continent, not like a full continent, and certainly never an incontinent. That doesn't make it any less interesting, though. These days, the area is still volcanically active. The eruption rate dropped a lot over time and has stayed relatively low ever since, but the system is still going. And that's already pretty wild, because activity like this usually only lasts 1 to 5 million years. So, in a way, the Kerguelen Plateau behaves like one of Earth's longest-running supervolcano systems. And it's still not done. Now quick, how many continents are there on Earth? You'd probably say 7, I would. But honestly, this question doesn't have a right answer anymore. Technically, yes, Earth has 7 continents. But our geography books have been ignoring this whole part of the world. For years, scientists have been arguing that there's actually an 8th continent hiding out there, and it's called Zealandia. Turns out this lost continent isn't so lost anymore. A few years ago, researchers finally mapped out exactly where Zealandia is and how massive it really is. And that was a first, because Zealandia is nothing like the other continents. Think about it. Asia, Europe, Africa, you can spot them from space, or better yet, just look down at your feet. Right now, you are standing on a continent. But most people don't realize every continent on Earth has parts we can't step on, or even see. A lot of their land is hidden under the ocean, and those areas are tough to map or even explore. Now, imagine a continent that's 94% underwater. That'd be almost impossible to find, right? Well, that's Zealandia, a massive chunk of land located beneath the Pacific Ocean. And there's a reason for that. A long, long time ago, Zealandia was part of Gondwana, an ancient supercontinent that included South America, Africa, Antarctica, Australia, and parts of Asia. For millions of years, Gondwana held together, until it started breaking apart about 200 million years ago. Its pieces slowly drifted in different directions, and one of them was Zealandia. At first, it was still connected to both Australia and Antarctica. But around 85 million years ago, Zealandia finally split off and began drifting on its own, becoming an isolated continent. Now, unlike Australia or Antarctica, Zealandia didn't stay on the surface for long. It sank. Today, only a small part of it sticks out above the ocean. That's mostly New Zealand, plus New Caledonia, and a few smaller Pacific islands. The rest is hidden under the sea. But hold on, how did Zealandia sink in the first place? For years, most experts thought Zealandia broke away in a process called a strike-slip breakup. That's when continents split apart along huge strike-slip fault zones, places where tectonic plates slide past each other side by side. But something about that theory never quite added up. After years of research, scientists think they have finally cracked the mystery. Turns out Zealandia's crust, or the outer shell of the continent, had been stretched thin. Yep, that's right. Instead of sliding sideways, like they once thought, the land was actually stretching and breaking. It's just like pulling a piece of dough until it gets so thin it finally tears. That's basically what happened to Zealandia. The land stretched so much it eventually snapped, and that happened because the tectonic plates beneath Zealandia were pulling apart, thinning the crust until it finally broke. And when it did, it cracked big time. The cracks were big enough for ocean water to rush in through the gaps, creating what we now know as the Tasman Sea. A few million years later, even more stretching left Zealandia's crust thinner and weaker. Eventually, it gave way, and huge parts of it sank beneath the waves, sealing its fate as a lost continent. But it wasn't all that lost. Experts had actually suspected its existence for almost 400 years, and the big clue was its unusual thickness. You see, Earth's crust comes in two main kinds. We've got continental crust and oceanic crust. They're both part of the planet's outer shell of solid rock, but there are some big differences between them. The continental crust is kind of like a Chicago deep dish pizza. It's thicker. The oceanic crust, on the other hand, is more like a New York slice, thinner. Now let's drop both slices into a tank of water and see what happens. Okay, let's just say the deep dish is lighter, so it floats. That's why continents sit above the ocean. The New York slice is heavier, so it sinks to the bottom of the tank. And that's why oceanic crust ends up lower, forming the ocean floor. There's another key difference too. Continental crust is made of lots of different types of rock, while oceanic crust is mostly basalt, that dark volcanic rock we get from eruptions. Knowing this, scientists used advanced technology to investigate the South Pacific. And what they found was surprising. Areas once thought to be ordinary ocean floor were actually basalt-free and much thicker than ocean crust should be. So wait, could our sunken New York-style pizza actually be a Chicago deep dish? Well, yeah. Even though Zealandia's crust is still thinner than other continents, it's way thicker than real oceanic crust, which means it's not just a patchwork of ocean floor and continental scraps. It's all continental crust, just a drowned version of it. In February 2017, scientists made the big announcement. Listen, everyone, Earth has 8 continents. Ta-da! But back then, they had no idea what Zealandia really looked like. There wasn't a map or anything, and that's probably why so many people still don't know it exists. Even inside the scientific community, not everyone was thrilled about calling it the 8th continent. Some people believe that the strange land at the bottom of the ocean was just a bunch of submerged fragments or microcontinents. Now here's the thing though, even before that big public announcement, an international team had already set sail on an expedition. They went near New Caledonia to collect seabed rock samples from North Zealandia, more precisely from Fairway Ridge in the Coral Sea. Fast forward 6 years, and those very samples unlocked a major discovery about Zealandia: its true size. The combination of rock dating methods, magnetic signatures, and tectonic mapping helped scientists define where Zealandia's boundaries lie. And they found that Zealandia has nearly 2 million square miles of landmass. To put that in perspective, that's about 20 times bigger than New Zealand. For many specialists, its size and completeness basically rule out the idea that Zealandia isn't a real continent. But why doesn't it feel official yet? I mean, we don't see it on maps, right? Well, that's because it's hard to get everyone to agree on calling it a continent. And the biggest reason people resist it so much might be pretty simple. It's just not convenient. You see, continents are generally identified by convention rather than by strict criteria. Depending on the perspective, people recognize 4, 5, 6, or 7 continents, because there's no such thing as a continent authority, and you are not going to see an international commission go on TV to name a new continent, or to make an official list of how many there are. Being almost entirely underwater doesn't help Zealandia's case. I mean, is it really fair to call it a continent like Asia or Africa? Some people argue that if Zealandia qualifies, then other smaller blocks of continental crust, like the Cocos Islands or other microcontinents, could also make the list. So, how many more continents would we have to add to the list? See why it's not very convenient? Maybe it's safer to call Zealandia a submerged or sunken continent. That's more accurate. Although, to be fair, the true definition of a sunken continent is still kind of fuzzy. But honestly, I wouldn't worry too much about the official definition of Zealandia. What really matters is that fully mapping it is already a big deal. Just keep in mind that large parts of it remain unexplored. Scientists are confident that technologies like seismic imaging and deep-sea drilling will uncover even more about its structure and history. And just because Zealandia is mostly underwater doesn't make it any less of a geological marvel. This sunken landmass actually preserves clues about Earth's past that we might never see on continents above the surface. It might help scientists understand how continents shift as the plates move around. They also hope to find more clues about how drifting continents affect sea level, climate patterns, and the distribution of plants and animals. Each new discovery could sharpen our understanding of how Earth's surface reshapes itself. So, continent or not, Zealandia has already changed how we see our planet.
A long, long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region: a strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still, scientists haven't put the Wilkes Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Lithospheric crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. But the Lithospheric crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Lithospheric impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, that asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future.
Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in two main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's eighth continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the fourth largest island in the world completely surrounded by water, but it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island that's 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution, even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future. New Zealand is located in the Southwest Pacific, and it isn't just a country of mountains, the world's quirkiest creatures, and hobbit holes. But here's another cool fact. New Zealand sits on top of a hidden continent that's 94% underwater. That's right, just the tip of a sunken landmass more than half the size of Australia. And with sea levels rising, one question keeps, surfacing. Is it possible that all these remarkable creatures will need swimming lessons one day? Zealandia is a sprawling, drowned continent stretching from New Zealand to New Caledonia. This underwater region has mountains, valleys, and its own geological personality. But wait, how can something underwater be called a continent? Well, it turns out being underwater doesn't disqualify you from being a continent. It just makes you harder to spot. Most people think of continents as giant land masses you can walk on. But geologists don't define continents by what's above water. They define them by what they're made of. You see, most of Earth's crust is oceanic, thin, dense, and made of basalt. However, continents sit on continental crust, which is thicker, lighter, and much older. That's the case with Zealandia. Even though it's mostly submerged, it's composed of the same kind of crust as Australia or South America. It has mountain ranges, sediment basins, fault lines, it's not your fault, and even fossils that prove it once had forests and land creatures. Zealandia was above sea level during the age of dinosaurs, and while we haven't found a raptor-like theropod skeleton yet, there's no reason to believe we won't. So how was this discovery made? Since most of Zealandia sits about 1/2 to 1.5 miles underwater, it wasn't easy. We can't drain the region like a bathtub just to take a look. So the answer had to be technology. Scientists used satellites to calculate tiny changes in Earth's gravity to spot what was hiding under the waves. Yep, fun fact, there are satellites that can measure gravity now. For example, NASA's mission GRACE has 2 satellites that find small changes in Earth's gravity. It does this by measuring how far apart the satellites are as they move over different things. Scientists also use sonar to map out the underwater mountains and valleys in 3D. Finally, deep ocean drilling pulled up ancient rock, soil, and even land-based fossils from beneath the seafloor. Physical proof that this wasn't just the ocean floor. Not that scientists use all this tech in that exact order, like following steps on a checklist. It actually took decades of overlapping data from land, sea, and space to connect the dots. By the early 2000s, enough evidence had piled up that some geologists began to speak openly about a possible hidden continent. Still, it wasn't until 2017 that Zealandia was formally proposed as one, backed by clear geological criteria. And in 2023, after decades of mapping and research, Zealandia became the first continent to be fully mapped while almost entirely underwater. But why did it sink in the first place? Long ago, all of Earth's land was joined in a single supercontinent called Pangaea. Around 200 million years ago, yeah, I wasn't around then, it began to split apart. The northern half became Laurasia, which included what is now North America, Europe, and most of Asia. The southern half became Gondwana, made up of present-day South America, Africa, Antarctica, Australia, India, and Zealandia. About 85 million years ago, Zealandia broke off from Gondwana. It used to be connected to Australia and Antarctica, but when it split, its crust became too thin and stretched out. That made it less sturdy and more prone to sinking. You can think of it like a piece of ice that floats lower in the water after it breaks off a bigger chunk. Over time, tectonic forces, like plate movement and the loss of its deeper support, caused most of it to sink. It didn't just sink because it was weak, but because it was pulled down by Earth's shifting plates. It settled lower into the mantle because it didn't have the structure to stay higher up. Today, only the highest ridges, like New Zealand, remain above water. That's kind of cool to think about. If Zealandia had never sunk, Wellington would be somewhere up to 9,800 feet high. That's higher than Aspen, Colorado. Now, we know New Zealand is packed with weird and wonderful animals, birds that can't fly, bugs that glow, sheep that outnumber people. But what about its underwater world? Is it just as special? Actually, yeah. And honestly, maybe even cooler. Zealandia's sunken edges are home to marine life that's just as unique and isolated as the wildlife on land. We're talking thousands of species that evolved in near total obscurity, tucked away on a submerged continental shelf. Think of it as Earth's secret underwater lab. This is all thanks to diverse temperatures and over 50 different habitats in coastal regions alone. Take fish, for example. Some are delicious. But around 300 species found in these waters are endemic, meaning if you don't live near New Zealand, you'll never see them. This cute little fish is called southern lemon sole, and it stands out with its asymmetrical, pancake-like body and the odd habit of burying itself almost completely in sand, leaving just its eyes poking out. And the deeper you go, the stranger it gets. Zealandia's underwater slopes and canyons have creatures that feel like they were designed during a power outage at the Evolution Lab. My favorite is carnivorous sponges. Yep, sponges that eat meat. There are also sea daisies, which are small, flat, round creatures that don't seem to fit neatly into any specific family of animals. Scientists have discovered these unique little animals hanging onto sunken wood more than half a mile deep in the ocean. They're so unusual that researchers almost created a separate category just for them in the echinoderm family tree, which includes other marine life like starfish and sea urchins. And then there's the New Zealand scamping, a lobster-like crustacean that lives in muddy burrows on the ocean floor. This creature snacks on jelly-like blobs, ghost sharks, and pretty much anything that floats by. Even seaweeds are unique there, although they're not as cool as predatory sponges. Oh, by the way, an interesting fact about the regions close to New Zealand is that they hide active underwater volcanoes. The most famous one is called Brothers Seamount. It's located about 210 miles northeast of New Zealand. It's a massive underwater volcano with a crater at the top, constantly bubbling with heat and chemicals. What makes it fascinating is that these vents, called black smokers, support ecosystems that don't rely on sunlight. Instead, bacteria use chemicals like sulfur to produce energy, a process called chemosynthesis. These bacteria form the base of a food chain that includes species like tube worms and deep-sea shrimp, which are adapted to survive in extreme heat, pressure, and complete darkness. That's not typical for most ocean life, which depends on photosynthesis and stable conditions. Brothers Seamount is also loaded with metals like copper and zinc, making it scientifically valuable and, potentially, commercially tempting. So it goes without saying that Zealandia is incredibly important to scientists. It offers a unique window into Earth's geological and biological history. It's like a time machine and a natural lab that helps scientists piece together Earth's history. So, in the end, could New Zealand end up underwater due to water levels rising naturally with each century? If you're imagining New Zealand slowly disappearing beneath the waves, like a real-life Atlantis myth, don't. Even with sea levels rising, that kind of full-on submersion just isn't likely, even in the worst-case scenario. New Zealand's tallest point, Mount Aoraki, stands over 12,000 feet above sea level. For the ocean to cover that, it would need to rise by more than 2 miles. And unless Earth suddenly turns into a water balloon, that's not happening. Okay, but what about sinking? Could it sink like Zealandia did? Zealandia sank because it had a thin, stretched-out crust. It didn't have the strength to stay up. But New Zealand? It's sitting on the sturdy, lifted backbone of the continent. In fact, thanks to tectonic plate collisions, parts of it are actually rising every year. And not just rising, shaking too. Zealandia has active tectonic plate boundaries, which is why the region gets so many earthquakes and volcanic events. So, while Zealandia may be almost entirely underwater, New Zealand is holding its ground, literally. In other words, the Kiwi won't need swimming lessons anytime soon. Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangaea, or Pangaea if you're feeling fancy. The name comes from a Greek word which means all the earth. Pangaea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangaea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangaea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangaea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangaea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangaea, Pangaea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangaea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangaea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a 3-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardue Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. All these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the two fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aquifence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research. But this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
Now at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot. Ow! Even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore, but when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people. It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world. A quiet land of forests, lakes, and mountains. stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics, and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity: furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing, factories were humming, and immigrants were arriving in large numbers. But the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region. But that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers.
So stargazers were chasing the Perseid meteor shower, but instead, they got something more unusual and rare: a massive cosmic swirl in the sky. In August 2025, reports poured in from Maryland, New York, New Jersey, Illinois, Ohio, Nebraska, a total of at least 10 states, and Ontario, Canada. The ghostly spiral was floating over the highways, houses, and woods for almost 10 minutes before vanishing like a Penn and Teller trick. It bloomed, unfurled, and then just faded. The internet went nuts about the mysterious spiral. Witnesses snapped video with shaky hands, wondering what they just saw. And of course, theories bloom faster than wildflowers in spring. Some people thought it must have been a Perseid meteor. It all happened smack in the middle of the season for those shooting stars. But meteors blaze bright and fast, and this was slow, hypnotic, and weirdly beautiful. Then a rocket theory took hold. The United Launch Alliance's Vulcan from Florida was a prime suspect. But the geometry didn't add up, as that rocket headed east, not the Midwest. The timing and path just didn't align. Finally, the European dark horse entered the spotlight, Ariane 6. They launched this rocket with a weather satellite on it from French Guiana just minutes earlier. Some astronomers mentioned that it probably released frozen exhaust high in the atmosphere during its cleanup phase. That spinning fuel cloud could have caught the sunlight just right, creating a spiral that drifted in the upper atmosphere. People were able to see it for a good stretch before dissipation. What we do know is that the physics behind what we witnessed are normally part of the twilight phenomenon. As the upper stage of a rocket starts spinning in space, it dumps leftover fuel. In the upper atmosphere, that fuel instantly turns into ice crystals that scatter sunlight and form a spiral that looks like something spun straight out of a fantasy novel. It's totally natural and doesn't have to do with extraterrestrial civilizations like some people thought. Still, nothing's confirmed, but there are more similar glowing structures lately, mostly from SpaceX's Falcon 9 rockets. That's why they even have a nickname, SpaceX Spirals. In March 2025, a glowing swirl formed above Europe like a neon whirlpool, or the Milky Way got into a blender. The blue spiral stretched and spun steadily for about 8 to 12 minutes above the UK and further into Sweden, Poland, Hungary, and Croatia. The sponsor of this sky show was a Falcon 9 rocket that had launched from Cape Canaveral earlier that day. Once the rocket reached space, it dumped leftover fuel that froze into ice crystals, and people got to enjoy an amazing sight. Now, normally, SpaceX spirals come in a perfect vortex shape, but the one that appeared over Europe in 2024 had two faint, horn-like pillars of light. It's the only horned spiral we've seen so far. It photobombed the auroras over countries like Poland, Lithuania, and the Czech Republic. Earlier that evening, a Falcon 9 rocket launched from California's Vandenberg Air Force Base, carrying Earth-observing satellites. Another layer to the story is that there was a strong G3-level geomagnetic storm happening at the same time, thanks to a coronal mass ejection that crashed into Earth's magnetic field earlier that day. That storm pumped up the northern lights, which became the staged backdrop for the spiral's eerie entrance. Another SpaceX spiral example is from April 2023. Over Alaska, people who went out to watch the northern lights suddenly froze as a glowing blue spiral swirled into view. It was drifting across skies like someone had opened a portal to another dimension. Cameras caught it, social media went wild, and Stargate in the sky was suddenly trending. But as it turned out, the portal was no invitation from the Milky Way, but the aftermath of a SpaceX Falcon 9 rocket. Frozen exhaust spun in the upper atmosphere and reflected sunlight in a perfect corkscrew pattern, framed against shimmering auroras. The science was straightforward, but the sight was straight out of a science fiction film. Now, spirals aren't the only kind of weird atmospheric shows nature throws for us. In Italy in 2023, a massive red ring of light suddenly flashed high above a storm. Scientists identified it as an ELF, a type of transient luminous event. When a lightning bolt unleashes a powerful electromagnetic pulse, it slams into the ionosphere's nitrogen and creates a glowing red disk hundreds of miles across. The phenomenon lasted only milliseconds, but thanks to time-lapse cameras, it burned into memory like the outline of an extraterrestrial saucer. Normally, only satellites orbiting the Earth can spot ELVs, but in this case, the lightning bolt was at least 10 times more powerful than regular ones, so it was visible to humans on Earth. Another cool thing about it is that it looked like it was hanging in the sky, directly above the town of Posigno. But in reality, the massive halo appeared above central Italy and part of the Adriatic Sea. It was just a forced perspective that made it look like it was in a completely different space. You can only get the best view of some sky shows directly from space. Aboard the International Space Station, Orbiting 250 miles above Earth, astronauts once reported seeing two mysterious blue blobs glowing beneath them. From orbit, they looked like deep-sea creatures that had been misplaced in the sky, two radiant orbs pulsing against the blackness of space. It turned out that one blob was a massive lightning strike somewhere in the Gulf of Thailand. You can't normally spot those from the ISS as clouds hide them. But this one strike occurred next to a large circular gap in the top of the clouds, and the lightning illuminated the surrounding walls of the cloudy caldera-like structure. The second glowing blue blob was the Moon playing tricks with light. Because of where the Moon was lined up with the International Space Station, the sunlight it reflected had to pass through Earth's atmosphere before reaching the astronauts' cameras. And when light hit the atmosphere, things got funky. Tiny particles floating in our air, like dust, water, and other stuff, scattered light in different ways. Not all colors of light behave the same, though. Each color has a different wavelength. Blue light waves are the shortest of the bunch, which makes them the easiest to scatter in all directions. So, when moonlight passes through our atmosphere, the blue part of that light spreads out the most. That's why the Moon looked like a fuzzy blue blob with a halo instead of its usual white glow. It's the same reason the sky looks blue during the day. Sunlight hits our Earth's atmosphere, and the blue wavelengths scatter way more than the reds or yellows. Our eyes pick up that scattered blue light, and boom, blue sky. So, basically, the ISS astronauts weren't seeing a new phenomenon. They were seeing the same science that makes summer skies look so bright. Only this time, the Moon got the blue makeover. Then, residents of Newburyport, Massachusetts, saw a fire rainbow pop up out of nowhere on June 2, 2024. Now, technically, it's called a circumhorizontal arc, and it happens when sunlight hits ice crystals high in the clouds at just the right angle, bending into a slice of rainbow that looks like it's flaming across the sky. It's all about timing and angles. The sun needs to be over 58 degrees high, and you need cirrus clouds or jet contrails carrying ice crystals. Light passes through the crystals, splits, and suddenly, boom, a rainbow in the clouds, usually just peeking through gaps. It's not just Massachusetts. In Weatherford, Texas, on April 15, 2025, jellyfish clouds called Virga did the same thing. Ice was falling but never hitting the ground, creating a floating rainbow halo. And on April 25, 2024, in Ohio, photographers caught the crystals scattering light into perfect rainbow colors again. So, next time you're outside, keep your eyes peeled. Mother Nature loves to show off, and sometimes she paints the sky on fire.
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help." Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the endgame here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. See how the Antarctic Peninsula looks just like South America, but upside down? This isn't just a coincidence. It's the ghost of a 30-million-year-old breakup. These continents were once connected, but their divorce gave birth to an ocean current so powerful, it was capable of completely freezing Antarctica and shaping its landscape. Here's how it went down. Tectonic plates pulled a sneaky move and cracked open a ridiculously narrow passage in the ocean, about only 500 miles wide, forcing 4.5 trillion cubic feet of water to flow inside this geological straw. This was the birth of an ocean current stronger than the Amazon River. This ocean current, called the Antarctic Circumpolar Current, by the way, flows in a circular motion, going clockwise because of the strong winds that blow over there. This circular motion around Antarctica caused erosion, shaping the landmass of the continent into a circle, except for that stubborn peninsula, which is being slowly dragged east like a kid refusing to leave a playground. Wait, South America and Antarctica used to be one? Yep, a long time ago. South America, Australia, and Antarctica were all part of a supercontinent called Gondwana, which also included Africa at some point. Back then, South America and Antarctica used to be basically joined at the hip by a land bridge called the Antarctic Land Bridge, which just so happened to be a lush green forest and also a great dinosaur highway. Yeah, you heard it right. Dinosaurs. A 95-million-year-old dino, whose name I can't pronounce, sorry, was discovered in Australia, and scientists found out it had actually been a distant cousin of Argentina's Sarmientosaurus. Same jaw, same chisel teeth, same everything. These guys were like identical twins, separated by an ocean. How? Because back then, Antarctica wasn't a frozen wasteland. It was a temperate rainforest, like Oregon, making it a pretty nice travel route for a dino family. But the land bridge wasn't just for dinosaurs. About 40 million years ago, the ancestors of Australia's marsupials waddled to the land down under all the way from South America, taking the Antarctica route, another proof that these continents used to be connected. Things remained somewhat peaceful for the dinos and the marsupials until Earth's ground started moving. This is what a German scientist called the continental drift theory, back in 1912. Our German friend here basically looked at the coast of South America and went, "Hey, this looks like it could fit into the coast of Africa." Like a scientific Sherlock Holmes, he noticed what others had overlooked for centuries. The continents were clearly pieces of a larger puzzle. And he was right. Here's the deal. Planet Earth is made of many layers of rocks and metals, like a cosmic onion. The outermost layer, the lithosphere, is divided into pretty solid tectonic plates that move atop a layer of softer, somewhat molten rocks, like slippery ice. This is why the plates move. In fact, they've been rearranging Earth's face for billions of years, with supercontinents forming and breaking apart in cycles, like a slow-motion game of bumper cars. This movement might be pretty slow since most tectonic plates only move 0 to 3.9 inches every year, except for the Nazca plate, racing ahead at 7.8 inches, about as fast as your hair grows. But don't let their snail's pace fool you. These shifting slabs are the ultimate planet shapers. Their slow dance gives us everything from earthquakes that build mountains, like the Himalayas, to rifts that birth oceans, like the Atlantic. All because the oceanic crust is dense and sinks like a stone, while continental crust floats like a cork. It's this density difference that explains why continents exist at all. Without it, Earth would be completely covered by shallow seas. This slow-motion planetary renovation project is exactly what tore South America and Antarctica apart 30 million years ago. The plates under these continents started to drift apart in a process called crustal extension. It's like the lithosphere was pizza dough being slowly stretched until it thins and splits. As the crust stretched, it became thinner and weaker, eventually cracking like the surface of a drying lake bed. This whole thing gave birth to a new tectonic plate, the Scotia Plate, that emerged between South America and Antarctica, like a geological divorce lawyer. For a while, parts of this plate stayed above water as the last gasp of the Antarctic land bridge. It was Earth's version of that one thread still connecting your hoodie after the zipper breaks. These final connections might have persisted as chains of islands, but just like that fraying hoodie, the connection couldn't last forever. Eventually, this small but mighty plate became the final nail in the coffin of the land bridge connecting the two continents. Just like all the tectonic plates, this one was also on the move. As it expanded eastward, it opened a new passage of water called the Drake Passage, slowly covering the Antarctic land bridge with ocean water. The process was like pulling open elevator doors. At first, just a crack, then wider and wider until the connection was completely broken. This geographical divorce had chilling consequences. The new Drake Passage allowed the Antarctic circumpolar current to form, creating an endless loop of cold water that isolated Antarctica, shaped its land, and even cooled the entire planet. This current acts like a wall around Antarctica, blocking warm water and invasive species while regulating global climate. Eventually, Antarctica turned into an icebox that is 98% covered in ice sheets, and that holds about 61% of Earth's fresh water. Nowadays, this continent holds the title of the windiest, driest, and iciest place on Earth. It's a frozen desert where temperatures plunge below -128.6 degrees Fahrenheit, cold enough to freeze your breath mid-air. A layer of ice there can be more than a mile thick, and it expands even further in winter to cover an area larger than the continental United States. Today, if you want to travel to Antarctica, the quickest sea route is through the Drake Passage, a 500-mile-wide body of water that is narrow enough for the winds to scream across thousands of miles, transforming into monstrous waves that can tower up to 49 feet, though calm days create waves only 13 to 16 feet high. Still twice as tall as Atlantic waves, mind you. This is probably why sailors call this stretch of ocean the Drake Shake. But tectonic movement isn't just about shifting continents. It's Earth's ultimate life support system. You see, about half of our planet's heat comes from radioactive decay in the core. Thanks, uranium-235. Something like nature's nuclear reactor. This heat is behind everything from volcanoes to the very plate motion that once connected Antarctica to South America. And it only comes out of the core because of tectonic movement. Without this internal heat engine, Earth would be just like Mars. When the plates move and release heat, they also release CO2 gases into the atmosphere, regulating the temperature of our planet. And when the plates move underwater, they take a lot of this CO2 back to Earth's interior, recycling all this gas. This is why the plates can change our air, climate, and even the evolution of life itself just by moving around. But billions of years ago, these plates were not moving around. Back then, it was like Earth was wearing a solid ceramic shell with many cracks. But even without tectonic movement, the heat managed to escape through these cracks in a process called stagnant lid tectonics, kickstarting all life on Earth. And no, tectonic movement is not a thing of the past. Earthquakes are the living proof that it is not just happening today, but might repeat again on a more dramatic scale in the future. You see, to form supercontinents like Pangaea, smaller megacontinents have to dive beneath another. And scientists predict that a similar process might create a new supercontinent called Pangaea Proxima in 250 million years. By then, humans might be extinct or living on Mars, but Earth's tectonic dance will continue, even without us. Not bad for something that moves more slowly than a traffic jam. Turns out, Antarctica and South America used to be BFFs before all that tectonic drama split them up, like a messy breakup that literally froze one of them out. Now, they just awkwardly mirror each other from across the Drake Passage. Classic exes.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American Plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a tabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
There's a mysterious dent in our planet's magnetic field, and it's slowly growing. It stretches from South America to Africa, and what's horrifying is that it's weakening Earth's protection shield against the Sun. They call it the South Atlantic anomaly. And while most people on Earth don't feel its effects for now, satellites and spacecraft passing through it already do. Deep inside our planet, there's a giant ball of molten iron and nickel, the outer core. The metal inside is so hot that it's constantly moving and swirling. This movement creates electrical currents, and when electricity flows, it generates a magnetic field. This field surrounds the entire planet like a protective bubble. Without it, life on Earth would be in serious trouble. The Sun blasts out charged particles called solar winds that could destroy our atmosphere over time. Luckily, the magnetic field deflects most of these particles, keeping us safe. Other planets without magnetic fields like Mars lost their magnetic fields, got their atmospheres stripped away, leaving them dry and lifeless. And also, without the magnetic field, our technology and equipment gets all messed up. Satellites, power grids, and even airplanes could get hit by intense radiation. This would lead to communication failures, GPS errors, and blackouts. And now, something strange has been going on underneath the African continent. An enormous blob of dense rock deep inside the Earth, called the African Large Low Shear Velocity Province, has been growing and messing the magnetic field up. Scientists think that this weird rock-like thing is messing with the flow of the outer core, disturbing the magnetic field above it. That disturbance is what weakens the shield over the South Atlantic. It's like a crack in a windshield. It might not shatter immediately, but the weak spot spreads over time. Now, NASA is watching it closely. Satellites passing through this anomaly experience random glitches and shutdowns. Sometimes their circuits short-circuit from high-energy solar particles. Mission operators have to turn off systems before entering the danger zone, and it's only getting worse. The anomaly is drifting westward. This means that new areas could fall under its influence. What's even worse, it seems like it's been splitting in two, which means our planet has been developing two weak spots instead of one. And here's something crazy. Some scientists believe that this entire thing is part of a long-term cycle that's been repeating for over 11 million years. And that cycle would make our magnetic poles flip. North could literally become south, and vice versa. Earth's magnetic poles have flipped before, although the last time that happened was 780,000 years ago, way before humans started roaming around the planet. These reversals happen every few 100,000 years. Now, some wonder if our anomaly is the beginning of the next flip, but scientists aren't sure if we're overdue or just in a temporary phase. Luckily, if a flip were to happen, it wouldn't be instant. It would take thousands of years. But as the field weakens, more radiation would reach Earth's surface. It would mess up not just technology and equipment, but also us, and even animal migration patterns. Many animal species use Earth's magnetic field to navigate. And they even have some potential culprits that could have caused this weird thing. There are two massive, mysterious blobs of hot, dense material deep inside our planet. One is under Africa, and the other formed under the Pacific Ocean. They're called large, low-velocity provinces. Basically, huge underground rock-like formations. Both blobs are gigantic. Each one is hundreds of times taller than Mount Everest and stretches across thousands of miles. They make up 6% of the entire Earth's volume and are one of the biggest geological features inside our planet. They're also super weird and could be structured more like trees than some lumpy mountains. Scientists imagined them as softened rock at first, but based on recent imaging techniques, it looks like they might actually have jagged, branch-like structures extending upward. These are like branches of a tree. They could be feeding hotspot volcanoes at the surface, like the ones in Hawaii. Scientists still don't know exactly what these blobs are. However, they believe they control a lot of what happens on Earth's surface. Stuff like volcanic eruptions, earthquakes, and, of course, changes in the magnetic field. They may also be linked to supervolcanoes and mass extinctions. The eruptions that they could cause could be like the ones that happened in ancient times and possibly wiped out entire species. If the blobs are connected to supervolcanoes, they might have had absolutely insane disasters in the past and might even cause more troubles in the future. But they also help us control plate tectonics, which affect earthquakes and mountain formation. They might also contain material from Earth's early days, or even from Theia. That was the mysterious planet that crashed into Earth and helped form the Moon about 4.5 billion years ago. Finally, Earth literally breathes because of these blobs, which is insane. The Sun and the Moon's gravitational pull stretches the Earth slightly, making it rise and fall like a breath. But now, scientists found that this tidal movement is slightly off-kilter over the blobs. They literally interfere with how the Earth's mantle moves. These two huge structures actually actively affect how our planet behaves, which is super dangerous. We only recently learned how these blobs actually appeared on our Earth. It's all because of the sunken ocean crust. Over hundreds of millions of years, parts of the ocean floor have sunk deep into the Earth's mantle. These slabs of rock stacked up at the bottom. This way, they slowly formed these massive blobs of recycled crust. Scientists haven't agreed on whether the blobs are heavier or lighter than the rest of the mantle. One study suggested they are denser, which would mean they're made of heavier material. Another study suggested they are less dense, meaning they could be hot, rising plumes of lighter rock. The African blob is suspected to be one of the causes of the South Atlantic anomaly, but scientists are still investigating how exactly they are connected. Since the African blob is basically a giant dense blob sitting on top of the outer core, it could cause troubles. The African blob is hotter and possibly chemically different from the surrounding mantle. It could be disturbing the outer core, affecting the magnetic field, weakening it. Another crazy thing is that they might contain an ocean of water locked inside their minerals. Scientists discovered that huge amounts of water, as much as all of Earth's oceans combined, are trapped in minerals deep in the mantle. One mineral, ringwoodite, can store water inside its crystal structure, but it's only possible under extreme pressure and super hot temperatures, like in the deep mantle. So there could be vast hidden water reservoirs inside the blobs. Not literal bodies of water, of course, but tons of little water molecules weirdly locked away deep beneath the surface. If this water were somehow released, it could potentially trigger massive volcanic activity, or even affect global climate. But the blobs are not the only factor for this weird anomaly. Other factors also contribute, like the tilt of Earth's magnetic field, changes in the core's iron flow, and even plate tectonics. However, the large provinces are making things worse. They keep evolving somehow. Scientists think that it might be because massive columns of hot rock called mantle plumes are rising from deep inside the Earth. These plumes could be pushing the giant pieces of Earth's crust like tectonic plates around, especially in the Pacific Ocean. If this is true, then these giant underground blobs aren't just sitting still. They're moving, changing, and shaping the Earth's surface all the time, almost like they're alive. So what does this mean for the future? If the African blob continues evolving, the South Atlantic anomaly might get larger or shift further, affecting more satellites and spacecraft. Right now, there are still more questions than answers. Every new data point helps predict how it will evolve and whether we need to worry about the worst-case scenarios. For now, NASA isn't panicking, but they're watching very closely. Because whether it's a harmless shift or a sign of something bigger, one thing is clear: something deep inside Earth is changing.
So it turns out that you can't drive between South America and North America. And there's a simple reason for that. There are no roads connecting the two continents, not even a rudimentary one. Technically, you could try your luck crossing on foot, but let me tell you, that would be a huge mistake. The region that connects the two continents is called the Darien Gap. It stretches across southern Panama's Darien province and the northern part of Colombia. The only land route there is a 60-mile jungle trek. Crossing it can take anywhere from 3 to 10 days. It depends on weather conditions, how much you're carrying, and honestly, just pure luck. Chance plays a big role here, because this isn't some chill, relaxing nature walk. It's a harsh, extreme environment, known for being completely isolated and one of the most dangerous places on Earth. Still, people seem to forget that and go there anyway. Every year, the number of people crossing just keeps growing. In 2014, fewer than 10,000 people crossed the gap. In 2023, that number increased to 520,000. Now, you might be wondering, what are so many people doing in the middle of the two American continents, risking all that danger? Well, that's because the Darien Gap has become a route for refugees migrating to North America. But to get there, they face all kinds of dangers, from insect bites and infections to serious fractures. We're talking about a no-man's land. Since there are no police stations, immigrants must also watch out for thieves. Along the way, they have no choice but to rely on and support each other. Most people start the crossing with at least a tent or tarp, rain boots, water, and some food. But these things get heavy fast, and people normally can't carry enough supplies for the entire journey. At some point, people start drinking river water to avoid dehydration. But the water's full of bacteria and dirt, so it causes intestinal issues. And if things get serious, there's no medical help there. To make this whole scenario even worse, the temperatures are brutal, often hitting over 95 degrees Fahrenheit. Now, a small subset of people who venture through the Darien Gap are hardcore adventurers and travelers looking for a survival experience in the jungle. But this region is no place for a relaxing vacation. A group of tourists who went there in 2023 ended up getting jungle rot, a fungus that affects the feet. The situation got so bad that a woman had to be carried out by the group on the last day because she couldn't walk. No matter how prepared people are for the Darien Gap, in the end, survival mostly comes down to luck. Out there, travelers won't find cities with solid infrastructure where they can crash at a hotel and gear up for the next day. In some spots, they might stumble across basic camps right in the jungle. These camps might offer wooden platforms for tents, bucket showers, toilets, and even plates of chicken and rice. But it all comes at a price. Wi-Fi, for example, might cost $2 an hour, and that seems like a pretty good deal, considering there's no cell phone service on the trail. They pretty much lose all contact with the outside world. Now picture a dense rainforest with steep, muddy terrain. The hiking trail is littered with boulders and tangled with vines, like nature's own tripwires. It climbs sharply over a mountain, becoming a serious challenge even for someone in good physical shape. The area also gets constant heavy rainfall, which can lead to landslides, flash flooding, and extremely muddy conditions. The situation gets so intense that even the t-shirts and faces of those who make the crossing end up covered in mud. They'll also have to cross a lot of fast-moving rivers. A Venezuelan dad who recently went through the area with his 2 kids said their sneakers ripped apart on the very first day. That's how powerful the rivers can be. And they're deep, too. Sometimes the water reaches all the way up to their shoulders. But the dangers in that area aren't recent. For centuries, the Darien Gap was thought to be impossible to cross. The first Europeans who ventured into Latin America saw it as kind of a jungle training school. They totally knew about its dangers, but still, many adventurers tried to make the crossing in the years that followed. In 1854, for example, an expedition disappeared for 49 days in the jungle, battling starvation and exhaustion. Then again, in 1870, a group of 100 men set out to cross it. Even though they were well prepared and carried cutting-edge equipment for the time, they still suffered tremendously during the journey. They had to rely on incredible resilience to survive the challenge. Over the years, people who ventured in often ended up passing away from hunger, thirst, and even drowning in rivers. They also faced the risk of being attacked by dangerous animals like jaguars, white-lipped pecaries, and the fer-de-lance, a fast, irritable snake that is one of the most venomous out there. The area is also swarming with mosquitoes, which can spread serious health problems. Leaning against trees to rest can also be risky. This jungle is full of spiked chunga palm trees, which are covered in long black spines up to 8 inches long. Unfortunately for us, these spines are covered in all sorts of bacteria. Just brush against a chunga, and you could end up with infected wounds. And yet another danger is getting lost in the dense forest and never finding your way back to safety. These days, though, this risk is a lot lower. Some people have mentioned color-coded markers that help guide travelers and keep them from going the wrong way. If they see blue or green fabric tied to trees, it means keep walking. But if they spot red fabric, that's a sign they're going the wrong way and need to turn around quickly. Since there are so many dangers, why not just build a road through the Darien Gap? While it might seem like a good idea, building a road connecting Panama and Colombia isn't really that simple. The Darien Gap has a humid climate, tough terrain, and constant rainfall, which means any attempt to build a functional road would be highly challenging and super expensive. Even though there have been previous attempts to fill in the gap. See, there's a huge road system called the Pan-American Highway, which stretches all the way from Alaska to the southern tip of Argentina. Nowadays, this highway hits a roadblock right at the Darien Gap. But it wasn't supposed to be like this, as the original idea was for the road to go through there. Leaders from Latin American countries tried to make this plan happen in the 70s, and then again in the 90s. But a lot of people were against it, mainly because they wanted to protect the local communities and the rainforest. Since the Darien Gap is mostly untouched by humans, it's one of the most biodiverse places on the planet. It's believed that 1 in 5 species are endemic to the region, meaning they only exist in that specific area, like the Darien pocket gopher and the slatty slender mouse opossum. A road would have really damaged the ecosystem in the area, so the plans were scrapped. Eventually, an alternative was created to travel by sea. At least 2 companies started a ferry service connecting the 2 countries. However, the business wasn't profitable, and they ended up shutting down. Not long ago, Panama decided to close the Darien Gap route. Now they're sealed off with barbed wire fencing. It might just be a matter of time before other routes are created. But if you are an adventurer looking to visit South America, it's probably not best to wait for that. Traveling by plane to Colombia will always be a much safer option. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.